Hey guys, and welcome back. Over the past few years, there's been an explosion in the adoption of CCTV, largely as a reason of prices tumbling and the multitude of options that are on the market. Now, I wanted some CCTV for my house so that I can keep tabs on things whilst I work remotely. But I had a few absolute must-haves. Now, originally I'd gone down the route of having a unified Dream Machine.
Our most versatile unified gateway console is the Dream Machine Professional, integrating a powerful internet gateway, Ethernet switch, and expandable disk storage, all within a single rack, one unit form factor. Completely scalable, it's designed for modern businesses of all sizes.
And this seemed like the silver bullet all-in-one solution, but my opinions rapidly changed. I'm not going to go into too much detail about it, but in terms of being a jack of all trades, it was a master of none, and I had issues with getting the content off the device, so being able to back it up, and the fact that there was only one hard drive within the machine, which meant there was no redundancy. So I had a look elsewhere on the market, and that's where I settled on Frigate. Now Frigate seems to tick all of the boxes for me. It's free, it's open source, and the buzzword of today, it has AI image recognition. Now, no longer am I going to be bombarded with leaves moving on my driveway or wind blowing the trees. It's actually intelligent enough to have object detection. So I can track the things that I want to, be it an animal or a person or whatever else is supported. And it does this by using a Google Coral TPU. I'll come on to that in a minute. And the beauty of this setup is that it's hosted within Docker. I can view it with the inbuilt integration with Home Assistant, and it comes with all the benefits of my existing backup strategy. So that allows me to back it up to my NAS and then back it up to the cloud. I can even do that in virtually real time. So I don't have to worry about my machine breaking or it being stolen, my house broken into, etc. That footage should be stored within the cloud. On top of that, it's super lightweight, super responsive, and has a great UI. So let me walk you through some of those features and then we'll get into the deployment, and I'll show you even how to pass through the TPU module in Proxmox through to your Docker VM so that you can have AI accelerated CCTV. So if we go through some of the features of Frigate, we can see that it boasts AI object detection, and that's done best via a Coral TPU. It can be done on the CPU, but it's extremely intensive. And I recommend, if you can find one, that's the issue, a Coral TPU. Now, you can get either the USB variant or the PCIe variant. I opted for the PCIe variant just because I didn't want to have something that was dangling out of the front of my server, but it shouldn't really matter. The other benefit of getting the PCIe module is that mine is a dual chip, and the USB is only a single chip. Now, it doesn't really matter because the single chip can support multiple cameras, and I only have 2 cameras. So the dual chip is an absolute overkill, but it does give me some redundancy in case one chip failed, and who knows, resale value is maybe an important factor. There's a great UI within Frigate, which makes it really simple to browse through all of your recordings, all of your events, and download them to your device if you wish to. And as I've already mentioned, as I'm mounting this in Docker to my NAS, I know that all of my clips are backed up securely onto that infrastructure. Now, zones are pretty standard features, but Frigate supports those, and you can actually fine-tune them with a great deal of accuracy. Probably better than you can do on some of the more readily available tools out there, things like your Ring doorbell, etc. You can actually do this through coordinates on an image through a config file, and this gives you really granular control. And there's even more inbuilt logic into it, so you can set up specific zones for specific objects. So you might have a driveway and you only care about knowing if the car is there, you don't care about an animal, or vice versa, you get the idea. Another obvious feature is the bird's eye view, and that gives you a split screen view of all of your cameras in real time. Now, as I mentioned, Frigate is free to use. This video isn't sponsored by Frigate, but I like the product, so I'm happy to support it. There is a paid version, and that's $5 per month, and apparently there is better object detection. So having a look at the Coral TPU, the good news is that as of this video, it is in stock, so go and buy it. I'll drop a link in the description below if you'd like to support me in that. Now, the Coral TPU is a very simple device, but it's an ASIC. It's a specific device that's designed for this kind of workload. So it's something like 100 times more performant in AI object-based detection than your CPU will be. So that means with a simple USB device or the integrated PCIe device, you're going to be able to support up to 100 cameras really simply. And that's great when you compare it to some of the options out there. Now, the beauty of Frigate is that the hardware is quite minimalist, so if you don't have a big fancy server, don't worry about it. As I've said, that Coral TPU is going to be doing the most of the heavy lifting. And on top of that, you don't need any special fancy cameras. I'm using a Unify G3 Flex just because it seemed to get a right balance between decent image quality and affordability. And I highly recommend those cameras, and I'll link those down below. Now, you'll see on the website that you have a thing called an inference speed, and that's basically number of FPS, etc. So you want that to be low. Typically around 9 to 10 is about the right range for the PCIe that I'm using, and I'll show that later in the video. More recently, there has been support for a GPU. So if you can't get your hands on a TPU, you can actually use a GPU. So if you're doing a pass-through of a GPU to your Docker VM, you can make use of that. On top of that, Frigate also supports hardware acceleration for encoding and decoding of files, but that typically isn't an issue. So for this setup, I'm going to show you how to use a Coral TPU and pass that through to your Docker VM in Proxmox. Now, don't worry if you don't have a Coral TPU. As I said, you can use the GPU that's in your system, that will also work, or you can even use the integrated GPU on your CPU. And the process is similar, but not the same, where you'll need to specify which hardware you want to pass through into your VM. And you may also need to do some additional configurations through driver blacklisting, and I'll link that in the description below. But let's jump now into how you pass through a Coral TPU into your Docker VM so that we can give Frigate access to that hardware. Now, looking in my Proxmox, it's pretty straightforward how to do this. Now, if you're passing through a GPU, there's a couple of additional steps that you'll need to make sure that you complete beforehand. And that typically revolves around making sure that Proxmox doesn't claim the GPU for itself. So you need to blacklist the drivers, add something to the grub file to make sure that it doesn't claim that GPU for itself. Otherwise, you won't be able to successfully pass it through to the VM. And I'll link those instructions in the description below. Thankfully, for the Coral TPU and USB devices, it's much simpler. Because Proxmox, and it's Debian under the hood, doesn't have native support for the Coral TPU, we don't have to worry about any driver blacklisting, albeit I've done it just in case. So, to pass through the Coral TPU is quite straightforward. I've simply clicked on my Docker VM here in Proxmox, I've gone to the Hardware tab, and as you can see here, I have a few devices that are added to this virtual machine. So this USB device here is my Zigbee gateway for all of my lights, and I'll cover that in a separate video later on, but it's really straightforward to pass through. The bit that we're focusing on today are the two PCIe devices here. Now, you can configure this through the .config file in Proxmox, and it will be reflected in the GUI, or if you don't want to dabble in the command line, you can simply click Add and then PCI device. Now, if you're still on Proxmox 7, this looks a bit different. I've just upgraded to Proxmox version 8, and you now want to specify a raw device. So click raw device, and then this will show you all of the devices that are available on your machine for pass-through. Now, I've mentioned before about I/O MMU groups, and this is basically how all the components on your machine are carved up so that you can pass through specific pieces of hardware to specific virtual machines. And those groups matter because if you want to pass through group 1, for instance, anything that's assigned to group 1 will also be passed through. So you can only separate by group, not intra-group. So if we scroll down on this list, we can see that we have Coral TPU mentioned twice. Now, that's because I have a dual TPU chip. And the good thing here is they're actually on separate I/O MMU groups, so I can pass those through individually. So I've simply clicked that and then click Add. And when I've done that, it's then added it to this machine here. So you can see that it's assigned group 8 and group 9, which are the respective I/O MMU groups for my Coral TPU, and it's said that it's a PCIe device, which it is. So now when I boot up my virtual machine, those devices are accessible to it. Now, it can't use it at this point because, as I've mentioned before, Ubuntu, which is my Docker VM, doesn't come with the drivers installed. But that's a really simple process, just like installing any other drivers. So let's head over to the Google website and it will show you how to add the drivers for Ubuntu. So on the Google website, you can see the variations of the M.2 device that's available. Now, the interesting thing here, and I probably should have mentioned it earlier, so there are different key standards for M.2 devices, and typically consumer devices won't be an E key, but what you can do, and what I've done, is I've acquired an M.2 to PCIe adapter, and that's enabled me to put this M.2 slot into a PCIe slot. As I said, you don't have to do that. You could go down the USB route, and those are available at present. So going down on the website, we can see that we have instructions for driver installation on both Linux and Windows. On Linux, we simply need to check whether we've already got the Apex drivers installed, and if not, we need to go ahead and install those. And it's as simple as copying and pasting the instructions on here. Just be mindful of what you're pasting and any tweaks that you might need to make, but it should all be pretty straightforward. Once you've installed those, and hopefully you haven't got any error messages, reboot the system, then run the command that's listed in bullet point 5, and that should report with the IDs of the TPU chips. Now, I've got 2, so it shows 2, and I'll show you that now. So now that I'm logged into my Docker VM, and this is the same one that I've been using throughout all of my tutorial videos, and if I paste this command in, let's see what we get in response. Excellent. That's exactly as the documentation specified, and exactly what I was expecting as I pass through 2 PCIe devices. Now you can see those reflected within this command. So everything should be ready and working. So now let's hop into the Docker configuration file, and I'll focus on exactly where you specify these 2 devices to pass them through. If you've been watching some of my previous videos, you'll have seen where we've mounted devices to a container already, most namely in our VPN video where we pass through the device tunnel. So hopping over into my GitHub, I've put the config file there for you, and it's pretty straightforward. So let's walk through it. So we've specified that we want the stable release of Frigate. You can change that to the latest or the development builds if you want to, but I want something that's stable, so I choose the stable image. The next bit is the important bit where we've just specified the TPU. So there's a couple of options here. If you have the USB Coral and you follow the instructions for installing that, and you've passed it through within Proxmox, simply uncomment the USB here and comment out the Apex devices which we've just added. If, however, you have the same setup as me with the PCIe devices, I'm not using USB, so I comment that out, and because I've got 2, I uncomment these here. If you've just got the single TPU, then you probably want to use Apex_0. The last option here is for that hardware acceleration using the inbuilt iGPU. Now, I'm using a Xeon processor, and that doesn't have an integrated GPU, so I'm commenting that out. Now, you might think that that's bad because I haven't got hardware acceleration, but it really doesn't matter for what my use case is. If you have an iGPU, you might want to pass it through, and also this is the place where you would pass through and specify your GPU if you're using that, i.e. something like an NVIDIA card or a Radeon. The volumes are pretty straightforward. The first one just allows it to have access to the local time, so it can read and use that to timestamp your video clips, which is obviously really useful when you're trying to put together a timestamp. The next part is the config file, and we'll walk through that in a moment, but the config file is a little bit tricky, but once you've got the hang of it, it's not too bad. The next section is where the clips are stored. After that, you've got the recordings. Now, these are the longer format videos that Frigate creates, and typically what you'd associate with a CCTV recording. The last bit is the database, and that's the bit that keeps all of this together. So timestamps, link to videos, etc. The next section is quite interesting. We haven't covered this before, and it's a temporary file system. Now, you might want to do this so that it records to RAM first to limit the wear out of devices, especially things like SD cards, because you could run this on a Raspberry Pi. Now, the port section is configurable depending on how you have this set up. Port 5000 is where the web GUI is going to run, so you might want to leave that open so you can connect to the Docker IP and then port 5000. But you can also route that through using a traffic label as we've set up previously in my videos. So I put the traffic labels in there because I want to access this through HTTPS. But you also need to add in the RTMP feed. Now, this is an open standard for getting access to your cameras. There are other protocols out there, but my UniFi supports RTMP, so that's the one that I use, and this is the port that it uses. In your environment variables, you want to specify a password for accessing your dashboard. And that's pretty much it. You could also add some Authelia or IP whitelists to your traffic labels if you want to lock this down further, but I'm not going into that in this video. Now, before we deploy this, I mentioned that we need to set up the config file. If you go ahead and deploy this without setting up the config file, you're going to get a load of errors and it just won't work. So let's walk through my config file, and I'll upload a copy of this to my GitHub so that you can tweak it. Just bear in mind that this is set up for me, and there may be other options that you might want or might not want, so tailor this to your needs. Just refer to the documentation. So in the first section, we're actually specifying the cameras. Now, I have one in my garden looking to the back of the house, and I have one on my garage looking to the front of the house. And this is pretty straightforward. I just specify the resolution of those cameras. Now, these are 1080p cameras. If you had 4K, for example, very flash, you would just specify 4K. The other important part here is to specify the IP address of the camera. Now, this is that RTMP path. So you need to make sure that if you're segmenting your cameras onto separate VLANs, etc., that your firewalls are configured to give it access. If you're running this on a flat network, everything's in the same subnet, then you're absolutely fine. And just make sure that you specify the RTMP feed. Usually there's a trailing slash and a couple of characters on the end, and that typically denotes what quality of stream you're going to get from your camera. I have this to S0, which for the UniFi cameras is kind of full fat HD. And just to note that that operates on port 554. Different cameras will use different ports, so just make sure you configure it for the camera that you have. Moving down into the detect section. Now, because of the indentations here, this detect section applies to both of my cameras. You could do this individually, so indent it further, but both of mine are UniFi G3 flexors, and I want them to run at 25 FPS. Now, some people might be shaking their head and going, what the hell are you doing? That's quite high. It is quite high, but I only have 2 cameras. You'll also notice that I've set up a mask. Now, this mask is kind of the code coordinates for those zones, and we can set those up within Frigate at a later date and then copy and paste them into here. So there's a handy tool in the web dashboard for selecting it, and you literally draw a box over your camera preview and it will give you the coordinates that you can paste into here. It would be great if you could do that on the fly through the GUI, but I don't think that's a feature just yet. Next is the database configuration, and this just uses a SQLite database that we've touched on previously. Next is where we specify the detectors. Now, these aren't metal detectors, these are the object-based image detections. So we've gone through the process of attaching our Coral to our Proxmox node. It's either the USB or it's the PCI, or if you're using the GPU, that would be it in this case. And then we pass that through to our VM within Proxmox using the add PCI or add USB device. And then we've added the drivers in the Docker VM, but now we still need to tell Frigate what they are. So in this case, I've specified that they are of type Edge TPU and which PCI space they're in. So PCI slot 0 and PCI slot 1. And as you know, I've got 2. If you've just got the 1, redact the second one. Next, I've specified which objects I want to track. Now, I like to see which animals, we've got a cat, are in the garden and what it's up to. But the key thing here for me is people. I want to track people. Next bit I've specified are snapshots, and these are what it says on the tin. It's a snapshot, not a full recording. So you can have a quick glance at your timeline and see a snapshot of what took place. So it will be a bounding box around the item that was flagged. So if it detects a person, it will take a quick snapshot of that so that you can quickly see that, oh yes, that was a person, and that will be linked to an underlying recording. The next piece here is an MQTT server. Now, I don't want to get into that too much, but that is a protocol for sending messages over your network, and I use this to send updates to my Home Assistant. So in this case, I've simply specified the IP address of my MQTT container. That will receive those commands, and then that's plugged in via a plugin into Home Assistant. The next section is for FFmpeg, which is how Linux does video recording and encoding, decoding, all of that stuff. You might have seen that in my Jellyfin or Plex video. If you have a GPU here or an Intel iGPU, you can uncomment this and it will take advantage of your hardware acceleration. The output argument I've got here is important because at the end of this comment, I've told it that I want it to record audio. By default, it won't capture audio, but I want to do that because obviously that's kind of half of the piece of the puzzle. The next section is the actual recording. So I've enabled this, true. I've said I want 5 seconds to be retained before the event happens. So imagine somebody walks onto your driveway. As Frigate is constantly recording, but only records the incidents of note, I want it to actually begin the recording 5 seconds before that person steps onto my driveway. That might be useful to know which way they came from or if they crossed the street, for example. And I want to know 5 seconds after they've left, just in case there's any overlap. I've told it to retain it for 30 days, and I've told it to track the active objects of person, bird, cat, and dog. I've enabled bird's eye, which is that kind of split screen view of all of your cameras. I've dropped the resolution down just to make it more performant, and if I want to get full fat HD, you can actually click on those images and it will take you to the actual full res output of your camera. So now that we have this configured, we can go into actually deploying this within Docker. So I've copied over my config file into my compose folder, and I just need to simply run sudo docker compose up-d to get this running with the config file that we've put within the volume mount we specified. So let's deploy the container, and then I'm going to go and check it with Importainer. So Importainer, the container's up as running, so let's jump into the logs and just validate that. This is what the logs look like if everything goes right. If it hasn't gone right, you'll have a list of error messages. Now, they can be a bit odd, but it's usually a misconfiguration with your config file. So go back and double check that. If you are having any issues, drop me a note in Discord and I'll try and figure that out for you. But if you copy my config and tailor it, it should be up and running. So here we can see that the camera processor started for the garden and the garage. It states that it's found the TPU and the associated PCI slots with that, and everything seems to be fine. So fingers crossed, we should now be able to go and access the web GUI. And perfect. There are my 2 cameras on the default dashboard, and everything seems to be working. I can see things moving in real time. If I wanted to jump into a higher res, I can simply click on a camera and that will take me in. You can see in the events tab, I've got a few things already running. And on the debug page, you can see that the inference speed is 9.59, so you can reverse engineer that to work out how many frames per second you're getting. I'm getting around 100 frames per second here. And you can see that I'm processing at 25. Now, I mentioned about the zones and how do we set those up. So if you click on one of your cameras and you hit the debug button, scroll down, click show options, then you can click the mask and zone creator. So if you click that and scroll down, you can choose which zone you want to do by clicking on the add button next to zones. Unfortunately, this is hidden behind me. So you can see now that I'm clicking and it's creating a box, and those coordinates are being put into the zones section. So as I showed you on the config page, you simply need to copy those coordinates into your config file and restart Frigate, and it will pick this up as a zone that you can then track. So this is useful if you have a driveway, for example, and you only care about people coming in through the gate. So if you want to view recordings, you can just simply click on one of your cameras and then click recording. Mine have night vision, as many do, so you can actually get some cool footage in your nighttime. If I just click play, that's going to show a recording from last night. Unfortunately, it seems like I've got a spider web across the lens, which often will trigger the image detection because it's not quite sure what that is, and occasionally it might look like a dog or a cat. I don't know. So hopping into my recordings, you know I've got cat specified, and lo and behold, there's a cat. So everything seems to be working well for me. Now if I hop into Home Assistant, and don't worry, I'll be doing a video on this later, you can see that there is a Frigate integration. And this is as simple as clicking onto the integrations within Home Assistant and simply installing the Frigate app and walking through the configuration wizard. You just need to specify the IP address of your Frigate installation, and you can equally manually assign the RTMP streams for your cameras for real-time monitoring. So Home Assistant can directly connect to those cameras rather than having to route the traffic through the Frigate container. This is better for performance. But once you've got that enabled and configured correctly, you can head back to your overview, and here I've assigned it to its own tab for cameras, and you can see that this camera is available here, and there's a number of functions that you can have with it. So you can full screen it, you can turn on the sound, for example, you can hover over the top, and you've got recordings, you've got snapshots, and you've even got a handy download button. So you pretty much have all of the functionality of the Frigate web GUI within Home Assistant, which is amazing because I use this on my mobile device, and it's much easier for me to have access and review footage. So I hope you've enjoyed this video. I've shown you how to pass through a Coral TPU to Frigate to give you a free, open source, AI object-based detection CCTV camera system that you can choose to record to wherever you want, so you have complete control over your recordings. No longer do you have to have a third-party integration, and you can even use other cameras that are devised for other systems, i.e. I use my Unify cameras, but because it supports RTMP, I can use it outside of the Unify ecosystem. So hopefully with this setup, you've got something that's simple, configurable, and highly scalable. So I look forward to seeing how you use this. Drop some comments in my Discord. If you like this video, please like, comment, and subscribe, and I'll see you on the next one. Take care, everybody.